So dear students, in the previous lecture number 12 we have studied about the equation of motion of a body under the effect of central forces, derived the expression for total energy and angular momentum. So continuing the part 2, in lecture number 13 we will study the effective potential energy of a system. As in the previous part we have studied that the total energy consists of two terms: gravitational potential energy and this term, and we named this term as centrifugal potential energy. So one question arises that why we named this term as potential energy? Because we can understand, no doubt, it is a centrifugal term because it is due to rotational motion indicated from the presence of L here, angular momentum. But why this term is called potential energy? So this will be answered in our second part. So we rewrite the equation of motion of the reduced mass we derived in the previous lecture as mu r double dot Fr force mu r theta dot square, and as L is equal to mu r square theta dot, so theta dot is L upon mu r square. So if we substitute it here, L upon mu r square whole square, so it is mu r double dot Fr L square upon mu r cube. So we mark this as equation number 1. So as we know that Fr, it is a gravitational force between the two masses, and it can be written as negative gradient of gravitational potential energy. So our main emphasis is for this term. So to solve this term we take d by dr of L square upon mu r square. So it will be L square upon mu d by dr of r raised to power minus 2 L square by mu minus 2 r raised to power minus 3. So it is minus 2 L square upon mu r cube. So our circled quantity L square mu r cube becomes minus 1 by 2 d by dr of L square upon mu r square, and it will be like d by dr of L square upon 2 mu r square. So we mark this as equation number 3. So when we substitute the value of Fr from equation 2, L square upon mu r in equation 3 in equation number 1, then we get mu r double dot, it is equal to minus du by dr minus d by dr of half L square upon mu r square. So it can be written as minus d by dr common, it is u plus L square upon 2 mu r square. So this is mass, this is acceleration. So mass into acceleration is force, which can be written as minus d by dr of potential energy. So this we have studied in one of our previous lectures as well as in lower classes, that force can be written as negative gradient of potential energy. So this term in this bracket is called effective potential energy of the system, and it involves two terms, gravitational potential energy and the second term, centrifugal potential energy. So the question raised in the starting of the article, and we put this equal to u dash is answered. So the equation becomes mu r double dot equal to minus d by dr of u dash. Here u dash is effective potential energy. So this is answered now, that why we called it as potential energy. So these two terms are potential energy terms, this is kinetic energy term, and sum of the two is total energy. So dear students, whenever you are to go through the lectures, you have to watch the previous lecture as well for continuity. So now we come to law of conservation of energy. Law of conservation of energy is, in an isolated system, total energy is constant. Energy can neither be created nor be destroyed. So continuing this equation, mu r double dot minus d by dr of u plus L square upon 2 mu r square, multiply both sides by r dot, so mu r double dot into r dot u plus L square upon 2 mu r square into r dot. So this term, it can be written like this, d by dt of half mu r dot square, and this term, this cancels, dt comes forward, so it is d by dt of half mu r dot square d by dt of u plus L square upon 2 mu r square. We take it on the other side, d by dt of half mu r dot square d by dt of u plus L square upon 2 mu r square is 0. D by dt common, half mu r dot square u plus L square upon 2 mu r square is 0. Derivative of a quantity is 0, so it means this is constant. And what is this? This is the total energy. This is the total energy. Dear students, we have derived it here. This is the total energy. So in a reduced one body problem, the total energy is constant. So this completes the present part. Keep in touch. Thanks a lot.